Hi, so in this example, we're going to discuss a binomial distribution for IRS tax audits. So the chance of an IRS audit for a tax return with over $25,000 in income is about 2% per year. We are interested in the expected number of audits a person with an income has in a 17-year period. Given that the population follows a binomial distribution, find the probability that a person is audited more than 3 times in a 17-year period. Okay, so they gave us that it says the population follows a binomial distribution. Okay, and so therefore, let's write some of this down. So therefore, the first thing we need to note is that we're going to use the binomial distribution. And when it's given to us, that just means that all that criteria is satisfied. The second thing we want to note is the information given. So they tell us that the probability of someone getting an audit is 2% per year. And so that just means 0.02, right? The third thing that we note is that we're looking for the number of audits in a 17-year period, right? And in fact, they specifically want a person audited more than 3 times in a 17-year period. Well, if we think about it, how often do we file taxes, right? We file taxes once a year. So when they say a 17-year period, a person will not be audited more than 1 time in a year. Audited more than 1 time. And that's because it's a binomial distribution. Because it's a binomial distribution, we know that every event is independent, and this probability is fixed for every event that occurs. And so this would mean that we would be looking for the number of times someone is audited. So the random variable would be number of audits, right? And so we would be looking for the probability that a person is audited more than 3 times in a 17-year period. Okay, so we kind of get the idea of the scenario, right? So let's go ahead and just now do the problem. So I know that the number of total years I'm looking at is 17 years, and I know that I'm looking for audits more than 3 times in that 17-year period, and the probability I'm going to get audited is 0.02. So if I'm looking for the probability of being audited more than 3 times in a year, right, that's going to be the probability of 4, right? It does not include 3, so plus the probability of 5, plus the ... all the way to the probability of 17. And that's not really sophisticated, right, to add probabilities 4 through 17. That's about 14 different probabilities you would do. So let's work harder. Let's work smarter, not harder, right? So let's look at a number line. Right, and here's 0 audits to 17 audits. Now you can't have 4.5 audits, right? This is going to be discrete, right? And so therefore, let me grab another color. And so here, if I wanted, here's 1, 2, 3. Okay, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do that. Okay. And so here is the 3 marker. So I'm looking for more than 3, which only includes 4 all the way out, right? The probability of 4 through 17, right? Events 4 through 17 audits. Well, using the complement rule, couldn't I just take this 100%, right, minus the percentage, the probability percentage of X less than or equal to 3, right? Wouldn't that be easier if I could do 1 minus the probability of 3 plus the probability of 2 plus the probability of 1 plus the probability of 0, right? And so if we look at this, it would be less than or equal to 3, right? And so why not do that? Adding 4 probabilities is much easier than adding 14 probabilities, right? But we don't even have to do any of this. This is just building up the concept to what we're trying to really do. What we're trying to do is trying to get the percentage probability and subtract this probability X less than or equal to 3. Okay, so let me write this out in a nicer way. So the probability of X greater than 3 is equal to 1 minus the probability of X less than or equal to 3. Which means it's 1 minus binomial CDF of NPX, remember? So N would be 17 years, probability is 2%, and X would be, this is included. So we got to include the 3, whatever that endpoint is. Okay, so if we go to our calculator, okay, and we'll do 1 minus second bars binomial CDF 17.02 and the X value 3 and hit paste. And that gives you 3.09 and then e to the negative 4th. And that actually means that there's 3.000, 3 zeros and then 3. All right. 0.0003. And we can see from the answer here that that is correct.